Hello, everyone. Uh, hello. Hi,
Hello,
everyone.
David.
Okay. Let's give everybody a couple of minutes.
Yeah.
Hi, David.
Hey, Boom, how are you? Oh, Sigmund, before, while we're waiting for everybody, maybe we can chat a little bit.
Yeah.
You are waiting for me to give you a net list and bump maps, right?
Oh, yes, yes.
Okay. I will do that. Yeah, I started work on the HBM that the Siemens folks sent.
Mhm.
That's the first thing that we need to do, and from there, we'll generate the full net list.
Okay, sounds good. Yeah.
Okay.
Actually, during several weeks, me and my lab mates create a automation script for XSI and XPD. So if we have HBM or CPU netlist, we can create layout or a layout
Okay. Yeah,
aspects.
let me forward you then the email from Nathaniel that has the HBM in it.
Okay.
You can test it and see.
Yeah.
Okay, I just sent you that.
Okay.
This is good. Okay, I will then start working on the CPU and yeah, okay. Yeah, let me know if you hit any issues with this. You guys have good understanding of the XML, right?
Yes, yes, yeah.
Okay, yeah, we've beaten up that quite a bit.
Okay, sounds good. Thank you.
Hey, Michael. So just for before we started, I will need to drop off at 9:30 at 30 minutes past the hour for another meeting. I have to attend it. I have no choice. So with that said, Michael, let me question for you. What exactly do you need from me for the next? I think you're trying to generate something for the whole package. What do you need? What are you looking for?
I guess we were going to try and create replicas of all of the individual components that's consumed within that package. And
Okay.
if you had a physical location of where they're placed, then we would see if we could build that assembly. Now, is your assembly containing any 3D stacking, or is it only containing everything on one level on top of an interposer?
It's going to be just on the top level.
All right. Okay. So we just wanted, I guess, we wanted to see where the weaknesses are to recover to view the whole app, because yesterday's meeting we asked the question under the package assembly kit, would we be able to represent a 3D stack? And I don't think we can in this current structure. I don't think we can. And I don't think this is part of the design kit. I think it's part of the normal component package. So we kind of need to play around with that structure and see what the weaknesses are, because ultimately it comes down to the question then, should we even have this inside the assembly piece, inside the part model, or should we rely totally on the TSMC version? And the team was voting on yesterday that if TSMC are going to take their proposal to IEEE and get that as the standard, then there's probably no need for us to expand the JEP30 to include the assembly.
Mm.
So
the question I have about that is what are the timelines for getting this thing as IEEE standard?
I have no idea.
Okay.
They're going to what's his name? Mark. I think Mark Rose is going to took an action to get his colleague who's works on the IEEE committee to reach out to me, and then we have a discussion to see what's going on. I even raised with the JEDIC office last night about would JEDIC be interested in having a joint collaboration with IEEE to work on standardizing perhaps the TSMC option, so that it would work in a very smooth and seamless way with the JEP30 at the component level. And that's also an option. So
yeah,
there's a lot of unanswered questions here, but I think there's a lot of focus in the fire, and we see which ones is the right way to go.
Okay. Yeah, that makes sense.
That would make that would, one good thing that would do if we could get IEEE involved is that it brings TSMC into the fold of the JEP30s as well, because we would make sure that their format would work with the JEP30 format, and it would, you know, make it easier then for a better widespread adoption.
Yeah. Yeah, I was thinking about 3D stacking. So there's two sides to this, right? One is the assembly piece, where do you put these things? But specifically for JEP30 right now, is there an option to represent bumps on the top side versus bumps on the bottom side?
Yeah, that went in at least 2 quarters ago.
Oh, really? Okay. Okay, I've missed that. Okay, so then it should be doable. Okay. All right. So okay. So going back to my original question, without 3D stacking, what do you how do you okay? And given that assembly part, how do you want to proceed on that then? If this goes in the IEEE standard,
I until I haven't looked at the TSMC standard in detail, so I cannot answer that yet. I think we
okay.
need to. This is something that's going to happen after the new year, but as of now, I don't think I can handle it before then, because I'm only working another 2 weeks, and then 2 or 3 weeks, and then I'm going off on holidays for a month.
Oh, nice. Yes. Okay.
Yeah.
Okay. So
So you know, under the schema, from a classification of the position, we can do we have a classification that says underside or upper side. But from a if you had 3 or 4 components stacked vertically on top of one another, we do not have within the schema the Z dimension, the Z level. So I'm looking at the standard array here. We have everything in the standard array that defines the X and Y positions on that plane. And in some places, we have the ability to put in Z dimensions. Adding in a DZ into the standard array, I was thinking afterwards last night, could bring the 3D element into the equation, which means then that if I'm making the assembly and I want to place components side by side, it'd be no different than placing components one on top of the other. Now, I'm sure there's going to be many questions that will be asked, but that's right now seems like a very minor change to the schema to support that type of stacking. However, as you stack the stuff up, and then you, let's say, I don't know the right terminology, so I'll just use the word reflow. The Z dimensions are going to change because the solder will melt, and therefore it will collapse a tiny bit, and therefore the component that's on top is no longer at the same Z dimension compared to when you started off. And so do you want to cater for that change in the Z structure in this format? Is that something you want to do?
that is a good question, right? There are several. Here is a question, right? What is JEP30 intending to represent? If the intent is to represent a chiplet, right? Actually, right now, as a part model, it represents a chiplet or a package, right? And in that case, really what needs to be represented is the interface bumps, right? For example, if you take HBM as an example, you're not going to go and represent all the stacks inside the HBM, right? You care only about the bumps on the interface, which you're going to go and then put down somewhere, right? Because that is the final product.
That's correct.
So, right. So in that sense, thinking of any 3D stacked ICs, it's just basically it's turtles all the way down, right? You're going to have a JEP30 for the whatever chip is in the stack, right? You're going to have multiple JEP30s, but somebody's going to take those, put them together, and create a product for which they will only need to represent the interface bumps, right? That are going to go to the next level. And
That's
then,
correct.
right, that gets put on a substrate that with other things, and then only the interface represented, and then that substrate gets put on another substrate where only the interface would need to be represented, right? So that picture I imagine.
Yeah,
right?
Everything you said there is 100% valid. You've described it very good.
Yeah.
The
Now
question, yeah.
Right. The question then is, but that is basically JEP30 representing the final part. I think what you're asking and what the question here is, if I'm the guy that's putting the chiplets together and I want to represent it somehow to the tools, I would need to represent all these different JEP30s that I got from elsewhere. How do I put them together, right? Is that correct?
Yeah, yeah, but how to put them together before you put them together, they're all separate JEP30s. If you want to have something that represents the assembly of them together, then the question arises, is it better to do that through an enhanced JEP30 schema to enable that to happen, or do we entirely switch over to a TSMC format? And after we had that question yesterday, I was exploring the JEP30, and I said, I suddenly came to the realization that, this is not going to be so difficult to do, because we created an example of a die array in which we had multiple different interfaces all spread out on a 2D plane. And we were able to replicate that and duplicate it and create a terminal and numbering pattern that reached into the billions. And a very small modification to that structure would enable us to put in a 3D structure, which then raises the question. I said, what's the gap then between that and an assembly? And I don't see it. I see that we're almost there at the ability to represent an assembly. Now, I don't know all the ins and outs, because there might be more things in there, right? But it seems like it's a very small step. Now the question arises that if we have all of this terminology and structure and definitions already defined in a part, and we can leverage that for the assembly, wouldn't it make sense to do that as opposed to transition all this data over to another format?
So here's how I would answer to this question. I would go and look in the other format what information is there, right? Because I think, right, besides putting the final information about, okay, we have the bumps and this is how we put them on top of each other, is there anything else in that, right? What else is in that?
Yeah, I agree.
Right.
So I think we need to take that look.
Yeah. And I don't have access to the 3D blocks. You from Siemens should be able to take a look and see what else is there, right? Because there may be flow information. I'm pretty sure there must be a material information, right? Everybody, right? What is being put between it? Are they when it's 3D stacked, are they just on top of each other, or is there an interface layer in between?
Yeah, like in the printed circuit board level, like different
Yeah,
layers of fiberglass, and then you have resin in between. There'll be something similar structure in the silicon side, but there'll be different materials.
yeah, right. So
Yeah.
I think that will give you the answer. My thinking is really here's what I think. I think it would make sense for JEP30 to represent a 3D structure.
Okay.
Right, and not only dies stacked on top of each other, but also components put in a substrate, right? For example, if you have embedded components, you're gonna have pads in the inner substrate layers, right? And then you're gonna put a component that attaches to those pads, and those pads of the component need to align with that, right? So,
All right.
To me, at the very basic level, we have to be able to represent this 3D structure.
All right. So, do you want to represent the connection path, the trace between one bump and another bump internally? Do you want to represent the vias between one layer and another layer, and the connect and so the entire physical
No.
routing? You don't want to do that.
No, definitely don't want to do that.
Well,
That is already represented either in GDS or in ODB++, right? There's no point in trying to reinvent that, right?
Okay. Okay. So,
but at least, right? Remember, I guess the way I see this is twofold. One is for planning. I want to be able to represent a substrate that has the pads on top and bottom, right, for whatever is needed, but also the pads for all the components, which may be actually inside the substrate.
okay.
Right. Which, by the way, that thought, that put what that would require is you, I mean, JEP30 being able to present the stack up in a substrate. Right, because you don't want to be representing the path in terms of z coordinate, absolute z coordinate. You want to represent it as a metal layer, right? You say
right. So the substrate stack up is not done, but I don't see that being hard. You're still saying I do not need to have any traces of vias. So if you taking out the traces and the vias makes the rest of it pretty simple, relatively wise, right?
Yeah. Yep.
Okay. All right.
Maybe for maybe for this exercise we should also put some passives inside the substrate and see and get an exercise how we can represent those.
Okay.
We'll just make up some components.
And you okay to start this in late January?
Yeah.
Okay.
I'm actually happy that you don't need the coordinates immediately right now, right? Usually December is quieter month, and I can do most of my work during that time, right? So I'll be able to give you that information in January. We'll put in some passives inside the substrate and see how that looks.
All right. Okay. All right. We'll see how that goes, and I'll touch base with Tony again, and let him know of this discussion, just to make sure that decision, that the recommendation that we made yesterday, that we would just solely focus on TSMC, may not be final.
Yeah. My thinking is, probably something simple as the DZ. Although I'm a little bit, I don't
I'm
know
nervous
if
that it's too simple a fix.
What I'm concerned is that if you provide an exact DZ coordinate, people would need to keep that exact DZ coordinate in sync with the chiplet thicknesses, right? And basically, we have information represented twice. So if somebody adds another chiplet in the stack, they're going to have to go and update the DZ. What I personally prefer, and that's my personal opinion, is say, hey, I have these 5 chiplets, and they're stacked 0, 1, 2, 3, 4, 5 like that, right?
Yeah.
And then the DZs can be calculated based on whatever, right? If somebody knows how much the things are going to collapse, what the intermediate thicknesses are, they can go and insert that and so on, right? They're not directly tied to the DZ coordinate, right?
Yeah,
uh,
yeah. I think that's a better approach, because then it also means that as you process it and thicknesses shrink as a result of the process steps, the relationship of one component
Right.
to another component is maintained. Whereas if you use fixed Z's, you'll have a problem.
Yeah, and remember, as a human, I'm a lot. For me, it's a lot easier to deal with 0, 1, 2, 3, 4, 5 versus adding thicknesses, right? Which are 212 microns plus 217 microns, and then I get lost,
of
right?
course.
Right? So, and especially once you add the variability, right? That DZ coordinate is gonna lose meaning, right? Because people are gonna say, okay, you calculated DZ, but did you assume min, max, or typical?
Yeah.
And we go into all that discussion. Oh, I don't know, right?
Yeah.
So it's better just to define, this is 1, 2, 3, 4, 5. This is the order. That's it.
Okay. Does anybody have the definition of a 3D stack in a PowerPoint with the type of relationships that you're talking about specified?
No. What are you looking for in that?
Well, I need to describe this to Justin and the others, so that I can explain this is why we're going to make the changes to the Z to make this happen. So,
yeah.
And then when we put it into, when we finally do put it into the standard, you need to describe the standard to the community so that they understand what it is that we're doing. So is there anybody here on the call that could pull a few slides together to describe what David is talking about?
I can give you the slide. If nobody asks, since nobody volunteered, I'll volunteer myself. I can give you a quick slide on that.
Okay.
Right. Yeah, just keep it lightweight for now. It would be my recommendation.
Yeah.
Right. Since we don't know, when you don't know, best to keep it lightweight, and lightweight is usually more flexible.
Okay.
Okay. So Sinmin, okay, so we have just a couple of minutes left in this meeting. I need to drop off. I will work on the netlist. I sent you the HBM file, and we'll work for Michael to get some passives embedded in the substrate, and then we'll see in next year how that's gonna look. And now, Michael, I'll draw a quick slide to give you an idea of what's going on.
Okay. All right. Very good.
That's good.
All right.
Thank you.
All right. Thanks, everyone. Talk to you. Actually, quick one. Next week is obviously holiday, so no meeting. Happy holidays. Happy Thanksgiving. We'll meet again in 2 weeks then.
David, I don't know if James informed you, but I finished the JEDIC documents. We reviewed it with the task group. It's ready to go to the ballot process. I've sent it to James. He has put it on the site for distribution. So can you take a chance to take a look at it? It's got the process assembly design kit, the process substrate design kit, the material design kit.
Okay.
take a look at that, and I'll need a response by no later than Tuesday if you want any modifications done to it. Hopefully not,
Okay.
because it'll put me up.
Yep.
It'll ruin
Yep.
my Thanksgiving if I have to go through a lot of modifications.
Yeah. Okay. Sounds good. We'll do. I saw the email. I just haven't had a chance to react yet to it yet, but I will do.
Okay. All right. Thank you.
All right. Thank you.
Bye.
Bye.